All right, welcome. In this video, I'm going to be working AP Pre-Cal Homework 2-1. And so we're going to be finding a lot of zeros of polynomials, and we're going to also be solving some inequalities, maybe sketching a couple of graphs. Okay, but the graphs are definitely going to be less important than the zeros and the inequalities. All right, so find the zeros of the polynomial and give their corresponding multiplicities. All right, so for A, I'm going to say, all right, well, f is equal to 2 times x minus 3 times x minus 4 to the 5. So it's either the case, if I, pardon me, I got a little ahead of myself. I'm interested in where f of x equals 0. Okay, so it's either the case that these things multiply together, one of them has to be 0. So either 2 is equal to 0, which it's not, so that doesn't contribute a root, or x minus 3 equals 0, and that's x equals 3, or maybe x minus 4 equals 0, and that would happen at x equals 4. Okay, this is a single root, okay, multiplicity 1, and x equals 4 has multiplicity 5. Okay, h of x is 2x times x plus 3 times x minus 4. Now the 2x could equal 0, and that would happen when x was equal to 0. We could have x plus 3 equaling 0, or we could have x minus 4 equaling 0. Okay, so those are going to be my zeros, and then the multiplicities are the exponents on each of these things in their factored form. X is to the first power, so the multiplicity is 1. X plus 3 is taken to the first power, also multiplicity 1. X equals 4, that has multiplicity 2 because of the x minus 4 squared. All right, this one we're going to need to factor. So I'm going to look for a greatest common factor. I see it. I see 4 powers of x and a 6. Okay, so 0 equals 6x to the 4 multiplied by x squared minus x minus 2. And that thing in parentheses, that's the type of thing we can factor. We can think of two numbers that multiply to -2 and add to -1. This is one of my favorite polynomials. I use this one a lot, x squared minus x minus 2 and x squared plus x minus 2, because I know they work and I just kind of stick with them. That's going to be -2 and +1, being the numbers that multiply to -2 and add to -1. And so now I've got, okay, x equaling 0 from the 6x to the 4. Multiplicity is going to be 4. Got x equals 2 from x minus 2, that's multiplicity 1, and x equaling -1, which also has multiplicity 1 because of the exponent of 1 there and there. All right, now we've got m of x equaling x to the 4 plus 3x to the 3 plus 2x to the 2. This one's also got a common factor of x squared. Got at least 2 powers of x in all of these things. So x squared plus 3x plus 2. And I'm going to, just like the other one, keep it going with the factoring, looking for two numbers that multiply to 2 and add to 3. That would be 2 and 1. Okay, and so my roots will be x equals 0 from x squared. Multiplicity of that root will be 2. We've got x equaling -2, multiplicity 1, and x equaling -1, multiplicity 1. Okay. Then what else we got here? Okay, yeah, something a little different. Okay, again, greatest common factor is x, so I factor that out, and I'm left with x to the 4 minus 16. Yes, okay, I'm glad I saw this because I didn't see this happen in the notes, and I wanted to make you aware of how this could go. This really ties into what we're going to do in the third lesson. But I'm going to look at x to the 4 minus 16 and say, hey, that's a difference of two squares. So it'll be x squared plus 4 and x squared minus 4. And we have x squared minus 4, that's a difference of two squares. So I'm going to actually write those first, x plus 2, x minus 2, but there isn't anything I can do with x squared plus 4. Okay, if you think there is something you can do with it to factor it, go ahead and do that, factoring it, like at least with real numbers. And, then redistribute and see that you're not going to be able to factor x squared plus 4 into anything with real numbers and be able to put it back the way it was. Okay, so that's all I can do. That's fully factored. So I've got x equaling 0, x equaling -2, and x equaling +2. Okay. X squared plus 4, if you tried to find where that was equal to 0, it would pull you back a non-real answer also. And I'm going to point out that all three of these have multiplicity 1. This next one is going to be in some ways similar, some ways different. I'm going to factor the x squared. I've got 2 powers of x common to both terms, and I'm left with an x squared minus 25. Okay, so I might actually hold on to that and keep factoring x plus 5, x minus 5. And so I'm going to say my roots are x equals 0, x equals -5, and x equals +5. And then the multiplicities associated with those roots, x is squared, so x equals 0 is a double root. X plus 5 and x minus 5 are each there once, so they're corresponding to single roots. So x equals -5, x equals +5, both single roots, multiplicity is 1. All right, I thought we were done, but we are not. Okay, so I've got, again, I'm going to set it equal to 0, and factor out the greatest common factor, which is x. We'll be left with x squared minus 6x plus 9. Okay. I can keep going on that. X squared minus 6x plus 9, that's x minus 3 times x minus 3. So I'm going to write that as x minus 3 squared. And then I'll have, okay, well, the first x, that gives me x equals 0, and then the x minus 3, that'll give me x equals positive 3. The multiplicity of these, okay, x is just there once, but x minus 3 is there twice, so those are the multiplicities. All right, for the next one, I think same thing. We're going to factor out 2 powers of x and also a 3. So 0 equals 3x squared multiplied by, okay, I would multiply 3x squared by another x squared to get 3x to the 4. I think positive 10x here and positive 25. Okay, I see where this one's going. I'm going to factor it up. It's going to be very similar. This thing's going to be a perfect square because two numbers that multiply to 25 and add to 10 are 5 and 5. So I'd have x plus 5 times x plus 5. And so, okay, either 3x squared equals 0. That happens when x equals 0. Or x plus 5 could equal 0, and that would happen when x equals -5. And since both of those factors are there twice, these are both double roots. We could say they both had multiplicity 2. Right, so 2 more of these now. So g of x equals 2x to the 4 minus 7x to the 3 minus 6x to the 2. And so I'm going to factor out as much as I can. And look, I'm not going to be able to factor out the 2. Right, I can factor out x squared and be left with a 2x squared minus 7x minus 6. All right, so I'm taking the 2 and the -6, and I'm saying u times v needs to equal -12. These two numbers I'm looking for to help me factor. And then u plus v needs to equal -7. Oh, yeah, wait. I've copied something down wrong here, right? -12 and -7. Let me think about this. Yeah, all right, so for the sake of the problem here, we're interested in doing factoring, not doing quadratic formula. So I'm going to change this to a plus 7x so that then it's definitely going to be... No, that doesn't work either. It's the 12 that needs to be positive. Pardon me. All right, that's much better. So if u times v is positive 12 and u plus v is -7, it's going to be -4 and -3. So -4x minus 3x. And then everything else is going to stay the same. So I've got a 2x to the 2 and plus 6. Okay, now I can keep going. Say, what can I factor out of the first two terms inside the parentheses? And that's going to be a 2 and an x. I'll be left with x minus 2. And then the second 2, okay, I've got this -3x plus 6. My goal is to get x minus 2, so I need to factor out the -3. So I'll have -3, and then sure enough, I'll be multiplying by x and a -2. Right, then I can keep it going. Times x minus 2, factor out that x minus 2, be left with a 2x and a -3. Okay, and then, okay, from here, I guess I'm just going to need to give myself more room to work. I'm going to say, all right, either x squared equals 0, and that's x equals 0 with a multiplicity of 2. I could have x minus 2 equaling 0, and that would be x equals 2. That's going to be multiplicity 1. Or 2x minus 3, well, that would be x equals 1.5. Okay, but we're not going to be really writing mixed numbers anymore. We're a little beyond that. I'm asking you to take yourself to a level that's beyond that. And so we're going to call that 3/2, and that has multiplicity 1. Right, and here's another one, and with any luck, maybe this one I'll have typed it right. So I'm going to set it equal to 0. And I'm going to factor out a 3 and an x squared. And then I'll be left with, and I'm not making the same mistakes before, I can't factor out a 6 because 6 does not divide 9 or 15, but all three of those numbers are divisible by 3. So I'd be left with an x squared minus, no, a 2x squared minus 3x minus 5. Okay, so I take the 2 and the negative 5, and I'm looking for two numbers, u times v, that are equal to, that multiply to negative 10, while adding to negative 3. So it's got to be the 5 and 2. Okay, and I always like these, it's the same numbers that we were multiplying together in the first place. I think it's going to be negative 5 and positive 2. Okay, so this will be really nice. Negative 5 and positive 2. So I split out the negative 3x into negative 5x and positive 2x. I'm actually going to do, whoops, I got carried away with the undoing. I'm going to do positive 2x and negative 5x, but it really doesn't matter. Oh, wait, no. Do the rest of it in black. Most clear I can be. So plus 2x minus 5x minus 5. And then we're still multiplying by 3x squared, and that's all equal to 0. Okay, so I keep the factoring going. So, whoops, 2x times x plus 1. And that can factor out the negative 5 and be left with an x plus 1 there. And then 0 is going to equal 3x squared times x plus 1 times 2x minus 5. Okay, then that's going to give me, I'm going to need a little bit more room, 3x squared, that gives me x equals 0, and the multiplicity of that root is going to be 2. X equaling negative 1, that will have multiplicity 1, and x equaling 2x minus 5 needs to equal 0. That would be where x is 2.5. So you can say 5 halves, you can say 2.5. I'm just asking you not to write 2 with a half to the right of it, because that looks like 1 to me, and to many other people. Okay, so that's how we're going to write our zeros and their corresponding multiplicities. That was 10 of them. I think that was a lot. So let's move on to something new. All right, now we're going to find the values of x that make the inequality true. So what we're going to do is we're going to make a sign chart. Oh, and I've lost my problem. There it is. Okay, so I've got 2x times x minus 3 times x plus 4 less than or equal to 0. So I draw in an x-axis, and I'm going to label it with my roots. I've got x equals negative 4, x equals 0, and x equals 3. I don't care about the scale really at all. Okay, and I'm going to choose a test point. I'm going to choose one off on the far end, because that was a new idea that was suggested to me by somebody that was thinking a little harder than I was, I think. So I'm going to choose x equals 10. Right? 2 times x is going to be 2 times 10, which is a positive number. X minus 3, 10 minus 3, that is 7. That's also positive, and 10 plus 4, this is a positive number. That's going to be positive. Okay, so I'm going to put a little positive sign right there. Notice that all three of these zeros are single roots. I don't see any exponents anywhere. So all of these roots are going to correspond to sign changes on the polynomial. So it's going to change back to negative, then back to positive, and then back to negative. And if I'm interested in where this is less than or equal to 0, okay, well, it's equal to 0 here and there, and here, I guess, and less than 0 through here, and that was supposed to go on forever, and between 0 and 3. So, yeah, and we said less than or equal to, and that was why I colored those circles in solid. And so I'm going to say x less than or equal to negative 4, and also 0 is less than or equal to x is less than or equal to 3. Now, if we wanted to write this in interval notation, it would be negative infinity to negative 4, including negative 4, but not including negative infinity because it's not a real number, and also 0 to 3, both of them having kind of squared brackets because we are including those endpoints. Forward, I'll probably just be doing interval notation or inequality, but not both on a given problem. The thing is, though, you need to be able to recognize both in a multiple choice setting. And I was talking about in class, I know that if this is going to be tested, it's going to be tested in multiple choice. For reasons I don't think it would be useful to get into right now. But if it's going to be multiple choice, we have to be able to recognize equivalent forms of the correct answer, and that's going to be being able to fluently go back and forth from interval to inequality notations. Okay, so I've got this one. This is going to be the same idea. Make a number line, plot my roots. That's going to be x equals 2 and x equals negative 3. Okay. X equals 2 is a double root, so I'm going to actually write that in. And then I'm going to get a test point. I'm going to choose over here something bigger than 2. I don't know, maybe 4. So at x equals 4, I've got 4 minus 2 is 2 squared is a positive number. And then 4 plus 3, that's 7. That's also a positive number. So positive times positive, that's going to be positive. Okay, so I'm going to say over here, I've got positive. But at x equals 2, I've got a double root, so that would not change the sign of the corresponding polynomial. But x equals -3, that's a single root, so the sign will change. Okay? And if I'm interested in where this is greater than 0, okay, that's not going to include these points where it's equal to 0, but it's going to be very near them. And so that's going to be here and everything to the right. So I'm going to say -3 is less than x is less than 2, and also x is greater than 2. But if you want to write this with an inequality, be my guest. I just won't be doing that here. Now we've got -3x times x plus 2 times x minus 4 squared less than 0. Okay, just like before. I'm going to start with an x-axis. I'm going to label it with the roots. I've got -2, 0, and 4. I'm going to choose a test point on the far right edge. I'm going to choose x equals 5. Okay, I'm going to have -3 times 5, and that's a negative number. Then I'm going to have 5 plus 2, that's a positive number, and 5 minus 4 squared is 1 squared, well, anything squared is positive. Okay, so negative times 2 positives is going to be a negative. Okay, and that means to me that I'm going to start off negative here. But where was my double root? It was at x equals 4, so I'm going to say, hey, this is double. So the sign will not change. No sign change, we're seeing a bounce on the graph. And then the rest of these are single roots, so I will see a sign change. And if we were interested in where it's less than 0, okay, again, I wish this was less than or equal to 0. It's got these little points that we got to exclude, and I feel like that's kind of unlikely for multiple choice. It would be more like, hey, where's this thing greater than 0? Well, then it's between -2 and 0 only. I like that as a question a little bit better than this, where you have to either exclude certain points or include only certain points, which I think we saw in the notes. But either way, my answer is going to be x less than -2, and also 0 less than x less than 4, and x is greater than 4. All right, with the next one, just like always, I'm going to start off with an x-axis. I'm going to label that x-axis with the roots. The roots are going to be -1 and +3. Okay. X plus 1 is a triple root, so it has an odd multiplicity, whereas x minus 3 is a quadruple root. It's a root with multiplicity 4. That's an even multiplicity. Okay. And I'm going to choose a test point. I'm going to choose something bigger than 3, like 100. I'm going to have a positive number multiplied by a positive number. That will be positive. Okay. Then in an even root, I don't see a sign change. And then an odd root, or an odd multiplicity root, I will see a sign change. At x equals 3, the multiplicity of that was 4, which is an even number. So an even multiplicity of a root causes no sign change, not an even root. So if I'm looking for greater than or equal to 0, I'm going to say, all right, well, 0 here and there. Greater than between the two of these. And, well, there we go. It's all x greater than or equal to -1. So I'm going to say -1 up to positive infinity, like that. Okay, E. This one, I'm going to have to factor it first. So I'm going to factor out the x, be left with an x squared minus 8x plus 16, which itself can be factored. So it'll be x times x minus 4 and x minus 4. So now I've got it factored. Now I'm ready to sketch in an x-axis, plot my roots, which is x equals 0 and x equals 4. X equals 4 is a double root. So I'll be sure to write that down. And then I'll choose a test point. Maybe this time I'll do something different. I'll choose x equals 1 in the middle. Now, like I said in the video, you can plug into the original version, but I think it's much easier to plug into the factored version. So x is 1, which is a positive number. 1 minus 4 is -3, which is negative, but I square it and then it becomes positive. So I got positive times positive, that's going to be a positive number, and so I label it there. X equals 4, that's a root with even multiplicity. So I'm going to say, all right, it doesn't change signs, that's also going to be positive, and then x equals 0 is a single root, it did change there. Okay, obviously, I think we could switch around some of the signs of these inequalities and make these better problems for next year. But if I'm looking for greater than or equal to 0, it's pretty much the exact same thing that happened last time. It's just going to be all x that are greater than or possibly equal to 0. All right, with this one, same thing. I got to factor it first, and I see that there's at least 2 powers of x in every term, so I'm going to factor out an x squared. And so I'll have x squared times 5, -5, and -1. X minus 5, x minus 1. And that's going to be less than or equal to 0. Okay, now drawing an x-axis and say, all right, my zeros are at x equals 0, x equals 1, and x equals 5. Okay. Now maybe this time I'll choose my test point from somewhere to the far left. Maybe I'll choose x equals -1. But if you choose from the far left, there's going to be more negativity going on and there's more to think about. If you choose from the far right, usually you've got a bunch of positive numbers. Unless you've got, like some factors that are written backwards to what you would be used to. Hey, but I'm not scared. I can do x equals -1. X equals -1 will be x squared is a positive number. -1 minus 5 is -6. And -1 minus 1 is -2. So I've got a positive multiplied by 2 negatives, and that's going to be positive. Now I go in, and I forgot to label the fact that x equals 0 is a double root. Since it's a double root, I'm not going to see a sign change. It's going to go from positive to positive. But the other two are single roots, so I will see sign changes. I will change from positive to negative, and then from negative to positive. I'm interested in where this thing is less than or equal to 0. So this is one of those we're going to have like an extra point. We're going to have x equals 0, x equals 1, and x equals 5. And then where this thing is less than 0 will be in there. So I'll have x equaling 0 and 1 is less than or equal to x is less than or equal to 5. All right, here are some more. Now we've still got 4 more of these. But we made the decision that you needed 10 of each to ensure that you got the practice that you needed. That's something that's sometimes as math teachers, we underestimate the amount of practice that y'all need on something to truly master it. And, none of these things that we're doing here today are all that difficult. It's just that you need repetition to see all the different ways that it can play out. So that's why the homework is a bit of a slog. If you're like, dude, I already get this, then maybe you just, skip some of these, save them for before the test, use them to review, right? Because if you already get it, you get it. You don't need to keep practicing. All right, so I'm going to factor out 2 powers of x. I'll be left with x squared minus 2x minus 3. We're interested in where that's less than or equal to 0. I can keep factoring. So it'll be x minus 3 times x plus 1. All right, and so now I've got my factors and their multiplicities. I'm going to sketch the number line and say, all right, I've got x equals 0, x equaling -1, and x equaling positive 3. My test point, I'm going to go out here to the safe zone of x equals 5. So at x equals 5, I'll have x squared, 5 minus 3, 5 plus 1. These are all positive, and so I'm going to put a plus there. Okay, but then I need to label any double roots or roots with even multiplicity. I'm only seeing that double root right there. So x equals 3 is a single root, therefore I will see a sign change. X equals 0 is a double root, no sign change. X equals -1, single root will be a sign change. I'm interested in where this is less than or equal to 0. So it's equal to 0 here and there, less than 0 on this interval and that interval. So we can combine all these things and say, all right, well, it's going to be -1 up to 3. Okay, good. I was starting to worry. I thought that I had put one of these on here where it wasn't already set to 0, but if the thing is not set to 0, our first order of business is going to be to set it to 0. And what I'm going to do, because I prefer to have a positive leading term when I factor, I'm going to leave the x squared on the left. Had it been minus x squared, I'd have probably pushed everything to the right. But what I'm going to do is I'm going to rewrite this. Oh, whoops, I'm still in red. I'm going to be in black. X squared, I'm going to subtract 6x from both sides of this inequality, plus 5 is greater than 0. Now I can factor x minus 5 times x minus 1 is greater than 0. Yeah, I've got my factors, and maybe you're like, I could solve this with a sketch of the graph, and if you can, great, good for you. Solve it with a sketch of the graph. I can too, and I would probably prefer to do that because I'm not a big sign chart person, but at this point that's what we need to do. And I need you to at least have some level of experience with sign charts going into calculus next year. Whether you're going to A, B, or BC, I need you to have some degree of familiarity with what we're doing, because it turns out inequalities are kind of a big deal in calculus. We're really interested in where things are positive and negative. In fact, you already know why. We're interested in where the rate of change is positive and negative, and that tells us whether a function's increasing or decreasing. And that's what we spend a lot of time doing in calculus, and that's why I was occasionally kind of complaining when we were doing these pre-cal things, and they were talking about rates of change. It was really just calculus. This is just more on that front. So I'm going to choose something larger, or maybe less than 1, like x equals 0. I like to plug in 0. So at x equals 0, I'm going to have x minus 5 as a negative number times x minus 1 is also a negative number, and that's going to be positive. These were both single roots, so we're going to see a sign change at both places. If I'm interested in where x, or when this product is greater than 0, well, it won't be here where it's actually equal to 0, but it will be over here where I'm seeing plus signs, because it's greater than 0. All right, so this is where x is less than 1, or where x is greater than 5. Okay. Now, to just give you a picture of where we're going to go after a couple of more of these, we know what this graph looks like. It's a parabola that has roots, or x-intercepts at x equals 1 and x equals 5. So we could sketch the graph, and we can see the graph was above the x-axis to the left of 1 and to the right of 5. And that's how I generally like to solve polynomial inequalities, by sketching a graph, but that's based on what I'm good at and what I'm less good at. And so you should make those decisions based on your own skill set as well. All right, wait, oh, no, I thought it went to J. G and H? No, I and J. That's too good to be true. All right, so we're going to sketch the graph of the function by making a sign chart. And if you already know, like, you can look at this and be like, hey, f's a fourth degree polynomial with positive leading coefficient, so I know it's in behavior. That can help you sketch the graph too, but I'm going to do it what it says, make a sign chart, because I really want you to have that skill. So I'm going to start by factoring. Factor out a 4x squared, and then be left with x squared minus 9. And then that's going to be 4x squared times x plus 3 times x minus 3. Okay, now I'm going to make my x-axis, but this time I'm going to actually let it, give it a little bit of room. Okay, and then I'm going to label my intercepts of x equals 0, x equaling 3, and x equaling negative 3. And I'm still not really going to draw this to scale in x, because I really don't care that much. It's just a sketch. It's not an accurate graph. If it was, we'd give you a sheet of graph paper, but that's not part of this course. You can look at what the free response questions for AP Pre-Cal are. None of them involve graphing something on graph paper. So that's good for us. We'll use technology oftentimes to aid us with graphing. So x equals 0, that's going to be a double root, okay, because of the x squared there. I'm going to do a test point, just like always. Just like I'm solving an inequality, I'll choose x equals 5. Okay, so at x equals 5, I'm going to have 4x squared as a positive number, 5 plus 3 is a positive number, and 5 minus 3 also positive. So everything's positive out here. I'm going to put down a positive. Okay, at x equals 3, that's a single root. I've got a sign change. X equals 0 is a root with even multiplicity, so there's no sign change. Then at x equals negative 3, that's a single root, so I'm going to see a sign change. And then I'm going to actually sketch the graph based on, okay, well, I know these are the zeros here. That's why I plotted them. And, well, if it's positive forever after x equals 3, that means eventually it's going up to positive infinity. And kind of the same story to the left of negative 3. It's positive everywhere there, so we're just going to let it go up to positive infinity. We don't really know about the end behavior of these things yet, but we'll talk about that next time, and maybe you do from last year. All right, then we're going to see a bounce because it goes from negative to 0 to negative, but then it's got to catch back up with the rest of the graph, and that's going to be our sketch. If we needed a y-axis, which we don't, I would draw it in right here and label it like that. Okay, and then I'd have a really nice sketch of that graph. Okay. B, g of x is x to the 3 plus x to the 2 minus 2x. We're going to need to factor this. Factor out an x and get x squared, my other favorite, x squared plus x minus 2. All right, I'm going to keep going. X plus 2 and x minus 1. Get myself an x-axis. Then label my roots. X equals 0, x equals positive 1, and x equals negative 2. Choose a test point, like, I don't know, maybe x equals 2. Okay, at x equals 2, I'm going to have 2 times 2 plus 2 times 2 minus 1. Okay, everything is positive, so I'll see positive here. All three of those are single roots, so I'm always going to see a sign change at every 0. Okay, so I'm going from negative to positive to negative to positive. And no, these are the roots, these are the zeros, these are the x-intercepts, so I'm going to label them that way. If I'm going negative, okay, and that's the last one, it's going to go to negative infinity. You can't really see that, maybe I'll zoom out enough, yeah, there we go. And then it's positive between negative 2 and 0, and then it goes negative, and then it goes back positive. It's a pretty good sketch. Now, I thought about this last time when I was drawing my y-axis, that maybe I could draw it to snap 2, and that might be nice. Okay, yeah, that's pretty good. And so I might say that that's going to be my x-axis, and that'll be my y-axis, and that'll be my sketch of the graph of g of x. H of x, I've got 2x to the 4, 10x to the 3, and 12x to the 2. That's going to require some factoring. 2 and 2 powers of x. X squared plus 5x plus 6. Okay, always be careful with the 5 and the 6. Okay, because we did one earlier that was very similar to this but factored very differently. Okay, so two numbers that multiply to 6 and add to 5, that will be 3 and 2. And so I have my factors, that means I have my zeros, and I'll label those 0, negative 3, and negative 2. All right, so negative 3, negative 2, and 0. That's where all the actions happening on my graph. Then I'm going to, what was I thinking? Oh yeah, test a point. Something bigger than 0, like x equals 1. At x equals 1, I'm going to have 2x squared is positive, 1 plus 3 and 1 plus 2, that's all positive. So I'm going to see positive over there. Can I get one with a negative leading coefficient? Okay, good. Yeah, the last one will. Okay, because I'm always going off to the right and it's always positive. I don't want you to get the wrong idea that it's always just, you can just always start with positive. It really has to do with the sign of the leading coefficient, but more on that next time. Okay, all of these are single roots except for x equals 0, which is double. Didn't catch that. So I'm not going to see a sign change at x equals 0, but I will see a sign change at the other one. So going backwards, it'll be looking like that. Okay, that means if I'm starting from positive and I'm going to 0, it's going to look like that. Okay, that had the wrong concavity, and now y'all know about concavities, so I can't really get away with that like I could in Algebra 2. That does need to be concave up. So then it's going negative, and then 0, and then positive. Okay, so let's let it come down here, go back up. Hey, oh wait, whoops, I drew that bad because it's got to bounce, so I need it to be like, I need to force in like a point of inflection, really, right? Because I'm going from a maximum to a minimum, so there's got to be a point of inflection between there because of the smoothness of the polynomial. Okay, and that's going to be a more than suitable sketch. I'm going to draw on a y-axis because I'm just kind of psychotic like that. Okay, there we go. And now we've got ourselves a really nice looking sketch. I can even put in, oh no, it's going to snap too. It's going to make a weird looking x and a weird y, but I can work without, well, okay, there it is. Okay, didn't like that either. I'm going to give it one more shot. Okay, there. I think I got it paused before it took it away. All right, so this time I'm going to factor. All I can take is an x and be left with x squared, 6x, and 9. Okay, this factors into x plus 3, x plus 3. So I'm going to call that x plus 3 squared. Drawing my number line. Plotting x equals negative 3 and x equals 0. No, I'm doing a test point. I just always want to think about the end behavior, but you don't know that yet. I'm going to tell you about that next time. That'll be helpful. So at x equals 1, I'm going to have positive 1 multiplied by positive 4 squared. That's definitely a positive number. Okay, and x equals 0, that's not my double root this time. The double root is going to be at x equals negative 3. So at x equals 0, I am seeing a sign change, positive to negative, but at x equals negative 3, I'm not seeing a sign change because of the double root. So I go over here, I plot my zeros for my sketch. It's going from negative to negative. That means it's got to like bounce there. And then it's going to have to recover. That was not very good. I feel like I could draw better than that. And it's got to recover and go positive there. This is really not my finest sketch, but it doesn't matter. It's just a sketch, right? So then I go in and I, draw a y-axis, and that looks pretty good, and that'll be more than enough for us here. All right, I'm not sure what happened to problem F, but it got deleted, and G stayed, I guess. So we can do this. Oh boy, this has got a lot of factors. Okay, but this will be fine. It's already factored for us because I don't think we could factor this thing if it was unfactored. And I'm going to start with an x-axis. Plot my roots. So I've got negative 3, positive 4, positive 5, and positive 6. The 7 is just really there to distract you, I think. So negative 3, positive 4, positive 5, and positive 6. And I know, the scale is really bad here, okay, but I'm just going to have to deal with it. I'll still draw on a y-axis, and I'm still proposing this will still be a pretty good sketch. Better than what we could make, say before today, the skills we had. So I'm going to label my double root. That was at x equals 5. And I'm going to choose x equals 0, and I'm going to even commit to it being right there. At x equals 0, because I like plugging in 0, I'm going to have 7, which is a positive number, times negative 6. Negative 5 squared is positive. 0 minus 4 is negative, and 0 plus 3 is a positive. So I've got 2 negatives and 3 positives. 2 negatives multiplied by a positive, so this is going to be positive. Okay, other than that, I'm seeing sign changes at all of these roots because none of these are double roots except for 5. So sign change, but at x equals 5, no sign change. X equals 6, yes, sign change. Right, now I've got everything I need. Okay, I always recommend you start with the end behavior, so maybe I'll do that here. Okay, we'll go up to positive infinity, and down here we're going to go down to negative infinity. Okay, between negative 3 and positive 4, the function's positive, so I'm going to do that. Then it goes negative for a while, okay, but again, I need to be careful with that because it's going to bounce. I've got a little bit of vanity going on with my sketches. I want them to be as good as possible, and then there we go. Now, if I want to find a y-axis, I'm going to just say, okay, I know it's between negative 3 and 4, and I just decided it was going to be there. So I'm going to just draw in my y-axis. But if I want to find the y-coordinate of that intercept right here, this point, maybe I'll label it in green or teal. If I want to find the y-coordinate of that point, well, that's the point where x is equal to 0. So let me go in and let me say f of 0 is equal to 7 times negative 6 times negative 5 squared times negative 4 times 3. Okay, is this something I can do? Close, but maybe not quite. Okay, 25 times negative 4 is negative 100. This is some advanced arithmetic, at least for me. And 20 times, okay, then I'm going to do the 7 times 3 is 21 times negative 6, because I like my chances of doing 21 times negative 6. That's going to be negative 126. Okay, negative 126 times negative 100 is going to be equal to, I believe, positive 12,600. Okay, so that was maybe a bad idea, but I hadn't done any y-intercept stuff on this video or in this lesson, and that's important too. And I just want to re-emphasize that the y-intercept is where x equals 0. And we can find that using the factored form. It just might be, a really big number. That should probably also give you a good idea of why we aren't, drawing these things to scale. If we were, we'd need to choose some crazy scale in y, or, but if you go and graph these on Desmos, you'll see. The graphs are pretty wild. Okay, so that's why we're just sketching. All right, so g of x equals negative 2x squared. This is the last one, right? Yeah, that's it. Okay, so we're almost there. Negative 2x squared times x plus 1 times x plus 2 squared and x plus 3. I like how we're ending with these, though, because they've kind of got it all. I wish, oh no, I said I wish there was one with a triple root, but we're not solving inequalities anymore, and we aren't talking about triple roots on graphs today, so that'll be a different thought. Negative 2x squared squared. That'll happen at x equals, that'll have a root at x equals 0. Okay, -1, -2, -3. So there we have it. And now I'm going to choose a test point. I'm going to choose x equals 1. Okay, I'm going to have g being -2 times. So wait, maybe I'll just call -2 a negative number. Then x equals 1 squared is going to be positive. 1 plus 1 is positive, anything squared is positive, and 1 plus 3 is also positive. So I've got a bunch of stuff except for one negative, a bunch of positives, one negative, and so that's going to be negative. Okay, where are my double roots? X equals 0 and x equals -2. X equals 0, x equals -2. So I'm going to label all my zeros. Oh, I forgot to do the sign changes. Okay, well, at a double root, the sign won't change. X equals -1 is a single root, so the sign will change. X equals -2 is a double root, no sign change. X equals -3 is a single root, sign does change. All right, so I'm going down to -infinity. Actually, I'm going to leave it, and I'm going to just show you that, like, if these are your graphs, I'm all right with that, actually. You know, polynomials don't have any sharp corners on their graphs, and maybe you already knew that, but I think you probably need calculus to understand why that's true. And you know, if that's as good of a sketch as you can provide, I just want to make sure that you are not thinking that like you have to up your art skills between now and 2 days from now, or now and tomorrow, or now and later on today, whenever you're watching this. Okay, so that would be a perfectly fine sketch. Whether or not you wanted to include a y-axis, if you did, good, might help. Might look a little nicer. It was supposed to be, yeah, it was supposed to snap to a line. That was pretty ugly, so I think I could do a little better here, and then down there as well. Yeah, there we've got ourselves a couple of axes, a nice looking sketch. I guess depending on your definition of nice. But that's all for homework 2.1, so that's going to be all for this video. Thanks for watching.